Hello and welcome back to our second part of the AI series. And for today's video, we will be talking about AI in action, AI decision making for startups. I am Nirisha Manandhar, AI consultant at Lean Disruptor. So, a brief background of what we covered in the previous video. So, we started off with what AI is and is not, and we also understood AI a little bit before what it was before ChatGPT. We also visualize what created the buzz around the current AI trends, especially ChatGPT in November 2022, and the concept of next word prediction and foundation models. And last but not the least, we also used these existing tools efficiently with prompt engineering. Now, for this video, we will be talking about what it takes to build your own foundation model and if you can make it yourself or not. We'll also be talking about how to make the best use of the available foundation models apart from prompt engineering itself. I'll also be talking about the difference between open source and closed source models in the concept of machine learning models, AI models, as well as data a little bit. And I'll also be talking lastly about the decision framework for model selection when you're working with startups. So without further ado, let's get started. Now, again, a little brief recap of what we covered in the previous video. We did this thing with the next word prediction, where I gave us a very simple example of it's raining cats and dash, to which we all agreed that it was dogs. Now, we recall this very smart friend who had knowledge about everything and could do next word prediction very, very well. But again, it could only predict the next word in the sentence. But we also talked about why that particular task is a very, very sought after task in the field of natural language processing, especially in the field of generative AI. So we also touched a little bit on foundation models and how foundation models were these new and these generative models that had the capability of doing multiple tasks. And it's not that these tasks could not previously be done by other AI models. There were still these models that could do these tasks individually. For example, there were models that could do entity recognition, sentiment analysis, language translation, and so on. But I kind of reflected back on the concept of how smartphones became popular um, in comparison to like individual devices like an alarm clock, a camera, and a calculator, and so on. Similarly, foundation models, they took the AI industry and the AI research community by storm because these models were capable of doing multiple tasks all in one. So that was pretty much where we left off. Now, to give you a brief scenario of where things are after the Transformers architecture back in August 2017 that I also introduced in the previous video, there was GPT 1, 2, and then there was GPT 3, then there was ChatGPT in November 2022, and so forth. But again, this is a screenshot, or I would say a snapshot of April 2023. So if you're interested to check out how many large language models have existed on this day as we speak, or the most recent data, you can head over to the LLM time capsule by Octo AI, where you can see the most recent numbers for the LLMs as well as the most popular models that exist at the date that we speak. So, according to this, on September 6th, 2024, we have 135,575 text generation models that existed, and the 10 most popular ones you can see is Reflection Llama 3.170 billion parameters. There's Meta Llama 3.1 AP Instruct. Then there is Cohere models. There is Allen AI models. And there is Casual LM and so on. So yes, for the most recent ones, you can head over to this website and check it out. Now, let's move on to this idea of creating these foundation models ourselves. Now, these text generation models that we've seen so far, let's talk about if we can create these foundation models ourselves on our own laptops and so on. Basically, how do we obtain these foundation models? Now, for this, I'll take a very simple example of ChatGPT. Now, if anyone asks you what the full form of ChatGPT is, it is Chat generative pre-trained transformer model. Now, generative because again, it generates text mostly. For now, let's take the example of a text. It's pre-trained on a large amount of data. We'll come back to that a little bit later. And it's based on the transformer models, which came out again, as I said, in 2017. So ChatGPT, as we all know, is an example of a large language model that everyone calls is LLM. Let's touch upon this concept of why these models are called large language models and not just simply language models. Now, there are three major reasons for why the term large is associated with it. The first one is because it is trained on a large amount of data. And again, I'll come back to the specifics of specific quantity of these things that as I talk later. But again, these differ from model to model. But here we're talking around trillions of text, images, audios, and even video data in order to train or like pre-train these models. Secondly, they're also trained with large compute resources. Now, to simplify this, like this concept, now CPU would be like the processing unit that we have on our laptops. But now, in order to train these models, it's not CPUs that could come to work. I mean, obviously, it could be done, but like you would need powerful CPUs, or they're also known as GPUs, which are graphical processing units. And it's not just one GPU that you need to train these train these large language models. It's multiple clusters of GPU you'd need. So that's the second reason why it's called large language model. Thirdly, you can also imagine that these models have large number of parameters. Now, I touched upon this concept on my previous video as well, but like parameters of a model are directly proportional to the number of neurons that a model is made up of, right? So we'll talk about how many parameters, but for now, let's think about these three things. That's large data, large compute resources, and large parameters that make models large as a whole. Now let's talk about the specifics in the case of ChatGPT. So the first step here would be to obtain a base large language model for now. Now for this, what usually happens is like you take a large amount of text or a large amount of data, and in this case, it would be a chunk of the internet as a whole. And that would be around 45 terabytes of text, images, and so on. Now, once we have this data, again, obtaining this data itself would be quite a task because you'd have to get it in a particular format, scraping the data and all of that would be a lot of work. But for now, let us assume we have a chunk of the internet, around 45 terabytes of it. Then we have this magic algorithm for now, which again belongs to OpenAI. Let's not get into the depths of it, but we have this algorithm which is ready to intake this data and get the processing get the processing started. Now, what happens is the processing here, it takes a lot of effort, time, money, and so on. So as I talked about GPUs, it's 1023 A100 GPUs that you would need, and you would need to train it for 34 days. And this is where the millions of dollars go into. And for this, according to the sources that we have, it's around $5 million that OpenAI invested in order to bring this model to life. Now, after all of this hard work, what we get is a zip file with numbers. And you can imagine that there's not one or two numbers in this zip file, but like some billion numbers that represent the parameters and the precious parameters of this final model that we have, or at least for now, the base large language model. Now, as I said, these base large language model that's trained on the like a huge chunk of the internet with this magic algorithm that we have, it is capable of doing this one task, which is the next word prediction. But as I said, next word prediction can only do so much. As you can see, ChatGPT is not just predicting the next word. For example, when you type 4 plus 9 in ChatGPT, if it was just next word prediction, then it would not have been 4 plus 9 is 9. 4 plus 5 is 9, sorry. It would have been 4 plus 5 plus 6 plus 7, and so on. But because ChatGPT is not just predicting the next word, but it is also doing something more useful, which in this case would be addition. As an example, OpenAI thought that obviously next word prediction is not enough. It needs to be more useful for tasks like calculation, summarization, question answering, and so on. So it's like you have something that is smart, but it does not know the specifics of the tasks that you can give it. So for that, what OpenAI did was it incorporated this extra thing after the first step, which is called instruct-based supervised fine-tuning, which essentially means giving a role to the model that we're creating and instructing it what different roles would reply in different scenarios. For example, if you can see, this is just one data sample that they might have trained it with, where you can see there are three things. The first one is the role itself, which is either system, user, or assistant. And there's a content after every role, which says, if you as a system is Marv, who is a factual chatbot that is also sarcastic, then if the user says, what's the capital of France? You, as the assistant, should be able to say Paris, as if everyone does not know that already. So in this way, OpenAI curated this thousands of data samples along the same format where it mentioned what the role of the system would be like and what the what how would the model reply if the user asks a certain question and so on. So this process is known as instruct-based fine-tuning, where you're instructing the model what to expect in what kind of scenarios, and you're also fine-tuning it. So fine-tuning is still training, but it does not require the excessive amount of data, the compute, or neither the time. So you can say that it is a smaller form of training with lesser resources. So after instruct-based supervised fine-tuning, what we get is ChatGPT, which is GPT 3.5 Turbo that came out in November 2022. Now, having said that, there's also one little detail that I've skipped for here, which is one little extra step after the instruct-based supervised fine-tuning, which is the reinforcement learning with human feedback, right? But just to keep this video a little bit basic, I've skipped that part for now, but just realize that there is one more step around here. So for now, what we've done is we've taken this raw data from the internet. We have this magic algorithm where we do pre-training using self-supervised learning. And then we come up with this GPT-based model that is capable of doing next word prediction. After that, OpenAI did this extra step, which is instruct-tune supervised learning, which is a form of fine-tuning with these smaller samples of data. And after that, there is reinforcement learning with human feedback, which finally ends up at ChatGPT. Now, as I said, ChatGPT is just one form of these popular models that are out there that is more situated around language tasks like summarization, question answering, and so on. There are also other models which have been fine-tuned for specific tasks by different companies and not just OpenAI. You might have heard of Dreambooth, which is more towards the image side. DALI 2, definitely. There's Stable Diffusion, there's Midjourney, and so on. It has also been devised for tasks like speech and music, or even 3D rendering, for example, Dream Fusion, motion diffusion models, and so on. So by now, you kind of have figured out that to make a foundation model, or even to make this huge model that is capable of doing a lot of tasks, or to even be an expert system in a particular task like code or 3D or video and so on, it requires a lot of effort. And effort comes in data, it comes in compute resources, and it also comes in the parameters of building this special file at the end. So now let's talk about what you can do when you have access to these foundation models. And this is apart from prompt engineering that we discussed in the previous video. Let's talk about how you can use these models to their best usage. So let's think about this scenario. We know that these models, they have information about a lot of things, right? About the whole world, even maybe because of the chunk of internet that it was trained on. But what if you would want the model to have knowledge about information that's outside of the training data or that's outside of the chunk of the internet that it was trained on? So this is the same as thinking that you have a smart friend. And for example, there is this new discovery, research discovery that has been founded in some part of the world. Now, the idea here is in order to make your smart friend learn about this new research discovery, You do not teach your smart friend ABCDs from the very base, right? What you would do is you would give the smart friend uh, the research paper itself to read or a book to read so that they're knowledgeable. Or even like when you talk with the smart friend, it's okay if the smart friend talks from the book itself or the research paper itself or reads it out from the research paper itself. So that is the idea that I would like to use here, that retrieval augmented generation is something that we might be hearing about with these models. Now, this is how we make use of techniques that connect this very smart model to knowledge sources. As I said, you could connect it with a research paper, you could connect it with a file, a database, even the internet, so that it knows about recent things without having to train it from the very base. So this is just augmenting your very, very smart friend, your very smart model with sources of information. And so this is where most of the startup companies or most of the companies have been leveraging the use of LLMs specifically by engineering ways to connect LLMs to different sources and making that process right so that hallucinations are minimal and the work is still done. Now, coming to the point of hallucinations, what if the same technique is used for crucial tasks, such as, for example, legals or legal work or finance related work, right? So it would be quite risky if the model hallucinates in these crucial tasks. So if in case the results that you're looking for, they still aren't satisfactory, there is what you need to do the hard work, and that is fine tuning. Now, as I said, fine tuning is a type of training. Up until RAGs, this was not training. There's no training involved, right? There is data involved, but this data is just connected to the large language models. There's no such training or running the GPUs involved or spending dollars involved. But in this sense, what is happening is fine tuning requires you to have data in a particular format and also have the required resources in, like, for example, GPUs, and also a little bit of like money to, fine tune models that are available there. So, as I said, most of the tools or most of the use cases can be completed by leveraging these external tools, sometimes connecting with the internet itself or with databases itself, and so on. Most of the work can still be completed by that case. But in case, as I said, when your use cases are related more towards crucial or like critical tasks, such as legal tasks, financing, healthcare related tasks, most people, what they do is they switch to fine tuning so that their model is more situated in their data and does not hallucinate more or less. Now, this can be tricky because you'd have to find the right kind of spot to hit the fine tuning well. But again, it's pretty much hit and trial. And if you get the data right, there's high chances that your results would also be nice. So, having said that, with all of these models that we have, there's a huge question, or this huge overwhelming questions that startup founders, and especially people who are starting out in this field, they struggle with is what should they start with, especially when they're starting to experiment with something, right? So here comes the concept of closed source models and open source models. Now, open source might be something that you might already be familiar with when it comes to even CS, when it comes to code, even when it comes to data. There you have whether the data is open source or not, whether the code is open source or not, and so on. But in the case of models itself and AI models, the concept is pretty much the similar. Concept is pretty much the same. So first, let's start with closed source models, or you can say these are proprietary models, right? As the name itself suggests, proprietary models are models that are owned by a company. For example, ChatGPT is owned by OpenAI. Gemini is owned by Google, right? So these are usually accessible to the public with the help of a website. For example, chat.openai.com, Google Gemini, and so on. Else, it's also accessible with the help of APIs that the company gives you. That is after you pay a certain amount of money. So that is usually the structure of pay as you go, right? So it's owned by a company, it's accessible to you definitely, but only after you pay a certain amount, whether it's subscription fees and so on. So a few examples of these models, as I said, these are Gemini, the GPT-4, and the recent models that came out. There's Claude as well. These are proprietary models. On the other hand, there are open source models. Now, these are models that are trained by a company and they're made available to you in different forms. Now, at the minimum, you will be having access to the model architecture and the weights of the model, but sometimes the code as well is available, right? So these models, they're accessible from like the company website itself. For example, Llama would be hosted by Meta itself in its own like website, or it can also be available via platforms that are Hugging Face where you can download these models and so on. Now, some examples that you might have heard of is Llama by Meta AI, definitely. You might have heard of Bloom, which was a little back. Then there's Mistral 7B, there's Phi 2, there's Shema, there's Command R by Cohere, and so on. So these are open source models. As I said, at minimum, you will be having access to the model architecture and the weights, right? And sometimes even the code. Now, the other difference that you can see with open source and closed source models is that with proprietary models, they can be commercially used. Obviously, they do have terms and conditions, but in most cases, you can gain business value out of it, right? Because the structure is pay as you go, you pay, I mean, you get what you pay for, and you can use it however you would want to. But when it comes to open source models, it gets a bit tricky here because you might be thinking that open source models are available for public consumption in the sense most of the resources are already out. But does that mean that we can get business value out of these models? Now, here's the trick that not all can be commercially used. This highly depends on what the license of the model is, right? So there are many different licenses. I mean, I could definitely link a whole document of what each license means with the video itself. But for example, there's the Apache 2.0, there is MIT, there's BSD, and so on. So there are different licenses that each models would have. Now, whether you can use it for business value or whether it's just for research purposes, that would be differentiated with the license that's provided with the models. Now, for example, Command R, which is by Cohere, it has been mentioned that it can only be used for academic research purposes and not necessarily for business purposes. But on the other hand, Llama 2, for example, it can be commercially used and even fine-tuned, provided that whoever is doing that, they have proper agreements with Meta. So as long as the paperwork is good, you can go ahead and do it. So as I said, there are pros and cons of like both closed source and open source models, but there are some things that you should be knowing when you're starting out as to which models you can directly use, maybe for your startup, maybe for research purposes, and so on. Now, having said that, another very important thing that you need to be careful about is this concept of decision frameworks, right? So decision frameworks specifically when it comes to selecting your AI models and also deploying your AI models in production. Now, I'd say that there are 5 dimensions that you can compare these trade-offs between these Gen AI models for like different scenarios. So the first one is time to market. Again, I'll talk about it in detail later as well, but the first thing you need to consider is what is your time to market? How much is it, right? It would also depend on the internal skill sets that you have within your organization and also the customization time that would need for the models itself. The second part is your cost structure. There are 2 cost structures here. There is the infrastructure cost for like setting up the model, and also there's throughput costs once requests start coming to this model that you have deployed so far. The third part is the latency. How much are you good with the delay in the models with your users? Fourth is the flexibility and transparency, both with the system and with the data. And the fifth part is the security and governance features. So in this part, you would be concerned about how secure do you want your models and also who would be governing the models that are on play in your startup. So if we had to do a comparative analysis of these 2 models, depending on these 5 dimensions that I just talked about, so let's start with time to market. So it said that with proprietary models, it is easier and it's faster to go to the market, and it's also quick deployment because a lot of the architecture is already managed by the company that it's owned by, and you're basically working with APIs to just get your first MVP ready, right? But with open source models, it would take some time because these are available on the internet. Definitely, you can download it, you can start playing around with it, but it takes time to set up the whole architecture as well as the expertise to start working with these models. Secondly, Regarding the cost structure, right? So with proprietary models, as I said, it is a pay as you go structure. So it will be usage based fees. So for example, if it's $20 per month for some kind of API that you're using, the more you use the API, and as long as you don't hit the token limit for every like API that you buy, you're good to go. So it's like usage based fees. And definitely, when you need to fine tune these closed source models, you would have to pay someone, or like obviously, you'd have to send in more dollars to get the fine tuning done. Now, on the other hand, open source models, they're obviously free models. They're free to download. Maybe you might have to apply for it. For example, in Meta, for Llama, you might have to apply for the access and so on, but still, they're free to download and free to use as well. But when it comes to fine tuning, it definitely incurs costs because there would be costs regarding the GPUs and maybe sometimes the data collection as well. Now, the third dimension would be latency. Now, this is quite a contested dimension because there's no right answer for this. I wouldn't say there is a direct shot answer for which one is faster, which one's like slower. But for example, when you're using ChatGPT on the internet, on the website itself, or even Claude on the website itself, sometimes you might get a notification saying that, okay, we've hit our hourly maximum capacity, and so it would take longer times to respond. So in that sense, you could kind of feel like these closed source models, they would take a lot of extra time or a lot of time to respond to user queries. But on the same side, you can see that if you're paying for the API and stuff, OpenAI or like any other provider for the API would also make sure that you or your user requests are dealt with like minimum latency or like latency within a certain limit. So they would be ensuring that. On the other hand, open source models, as I said, they will be hosted somewhere maybe locally, or you're also hosting on the cloud after downloading it. So it depends where it's hosted, as well as it can be like often they're faster if they're smaller models, but again with bigger models, it will take time to get the first response running. Now, in terms of flexibility and transparency, as I said, proprietary models, because they're owned by this particular company, there is no code access to it. So the developers would probably have to deal with a black box and probably just communicate with the API. Whereas in terms of open source models, as I said, some models will also have their code open source, which means it will be full code transparency and also flexibility for your developers to start tweaking around with some parameters and so on. And last but not the least, in terms of security and governance, it might be a trade off because for proprietary models, there will be strong security because OpenAI, Anthropic, or even Google will be trying their best to have maximum security standards for their models. But on the flip side, you can also imagine how the data management inside these models might be opaque. You might get the API from like some company and then you might start to integrate, but it's also very crucial for you as a startup owner or a business owner to know where your user data is going, which might be opaque sometimes in terms of proprietary models. But in terms of open source models, again, as you can see, it can be secured locally, but that might be a little bit of work. But in terms of built-in security, because they're like pretty much models off of the internet, you would have to build that security yourself. So in terms of integrating these Gen AI models into your startup, right? This is not a very hard and fast rule, but again, some suggestions that you could use is that when you're in your initial product development and you're maybe in your prototyping phase or even the MVP phase, you can see that you can use the API based models because they're easier to integrate and they're also easy to tweak around and to work around if your solution works or not, right? Maybe for the, you could say for the user research part and so on. But as I said, once your product has obtained a good product market fit, and maybe you think that, yeah, this can go a long way, it needs to scale better in your domain, that is where you might want to switch to maybe open source models and also start fine tuning them and doing that on the side while the MVP is still getting some user feedback. So fine tuning, as I said, is available for both open and closed source models. The prices can differ heavily depending on who you give the data to, who is doing this, who is doing the fine tuning, and so on. But still, the options are still available. Having said that, There's also hybrid deployments. For example, one of your engineering teams can work with the API-based models to do their user feedback and get the product up and running in the market, whereas your research team can then go ahead with like researching with open source models and maybe doing the fine tuning a little bit on the side. So hybrid deployments are always possible. And there are also a few other last things that you need to keep in mind when it comes to model deployment. So first and foremost, there are different ways how you can deploy these models once it is out there in the market and so on, but there is this concept of Gen AI model as a service, which has been provided to you by different cloud providers. For example, there is AWS doing that, there is Azure doing that, and so on. So this is this concept of providing these APIs as a packaged service so that you can use it for different aspects inside your company. So these are mostly proprietary models. As I said, it could be even ChatGPT, it could be any like Google API and so on. So they will be managed by a cloud service and will be given to you as a service. So that's possible. Apart from that, if you have the right kind of money, the right kind of if you have the right kind of investment, the right kind of space, as well as the right kind of team to set it up, you can also go ahead and do a private cloud deployment. For example, you download a model off of the internet and you want to play around with it, but again, for maximum security and so on, for like managing your data very securely in your private space, you can go ahead for private cloud deployment. But again, this would take a lot of time and energy as well as a lot of investment in terms of both space or getting the GPUs ready or getting the data service ready and so on. Thirdly, you also have commercial cloud deployments. So what this would essentially mean is that, for example, you download Llama from the internet and you start working around with it, but your devices or your laptops or whatever your personal devices are, they are not ready or they are not, let's say, well equipped to deal with these models on your local server and so on. You could go ahead and deploy these models in commercial cloud, which are again provided by different cloud providers, and you can start working, or you and your team can start working as in these cloud services itself. And having said that, the last part is hybrid deployments are still possible if you have a well enough well enough device that can host a model that you can experiment with, and you would also want to deploy some closed source models in a commercial cloud, for example, that scales with your users. That is also equally possible. So yes, I hope this video was a good starting point for startup owners or anyone maybe from a non-technical background, even looking forward to integrating LLMs into their startups. And yes, feel free to reach out to me anytime for more questions, and we'll be back soon with more content regarding this topic.